Hi there and welcome to another college math video. In this video we're going to look a lot more at Venn diagrams. We'll specifically start looking at Venn diagrams with three sets and then we're going to also use Venn diagrams to prove De Morgan's law. So that takes us to our objectives, learn properties of Venn diagrams and De Morgan's law, and then use Venn diagrams with three sets. So we'll start with De Morgan's laws. Okay, so we're going to use this visualization to prove De Morgan's law. All right, so let's draw the Venn diagram and shade where the solution would come for each of these. So we have two sets in both pictures, A and B, so I'll set them up the same. And then ultimately we're going to shade where the solution would come from. So in the first one we have A union B complement. So remember the union would be the marriage of the two groups. The union specifically would look like this. Everything in the middle. If we want the complement of that, then it's everything on the outside of the two circles. So for this, the visualization, the answers would come from this shaded region. Okay, compared to A complement intersect B complement, we can draw each of those individually. Here's A complement, everything outside of A. And then B complement is everything outside of B. Imagine if the two were on top of each other, where would you see shading from both? Or where do you see shading that the two have in common? They definitely don't have this middle region. The part that's just B is not in both of them. The part that's just A, it's everything outside of the two circles. So this answer would come from this shaded region. So these are our two final answers. These were just helpers along the way. We don't need them. And so looking at these two pictures, you can see that they are equal. So even though they symbol-wise said very different things, A union B complement and A complement intersect B complement, they ultimately represented the same information. So this is the first of De Morgan's two laws. A union B complement is the same as A complement intersect B complement. Now I'm drawing the picture with you to prove to you that this is the case, but really what I need you to be able to work with is the law itself, or to use as the law itself. So that's the first of the two. The second one, again, we're going to prove visually. The second one, the first thing we want is, let's set up the pictures for both, with sets A and B inside of those universes. The first one is A intersect B complement. So A intersect B, remember, is just the middle area. So if we want the complement of that, it's everything except that. So we'll shade everything on the outside. And leave the overlap unshaded. And then the second one is A complement union B complement. So here's A complement. Here's B complement. And if we want to pull those two things together with the union, it's the marriage of the two. So anything you see shaded in either one is shaded in your final answer. So the shading, surprise, surprise, will be the same as the first one, or the one on the left. So again, you can see that these two things are equal, which means that symbolically those two represent the same area. And so from here we have the second of De Morgan's two laws, that A intersect B complement is the same as A complement union B complement. So let me just point out that those are the two of De Morgan's laws in their purest form. And you might recognize or notice that it sort of looks like the complement in this parentheses is sort of I hesitate to say distributed, but just given out to each item inside. So if they both start as the regular version, then they become the complement, and the symbol inside flips. And that's the truth. You might notice that for both of them. That's definitely the truth. But I just want you to know that the law doesn't have to be applied in that one way. The law can also be applied on any sort of modified version. So if I asked you to tell me what was equal, what was another way to write this statement, using De Morgan's law, you can distribute or give that complement on the outside of the parentheses there to each item inside. So instead of A, it'll be A complement. Instead of B complement, the complement of the complement is back to normal. It's sort of like saying you can't not eat pizza. It means you can eat pizza. So it goes back to regular B, and then you flip the symbol. This is another way to write that. And you could draw the picture for each of these, each shade one picture for the left, shade one for the right, and you would see they represent the same thing. But like I said, this is just using De Morgan's law in a different way. And it doesn't have to be that you start with the parentheses and go the other way. I could also ask you to take this statement without a complement on the outside and write an equivalent form of it. You could also pull a complement out of that and then change basically everything inside. So A becomes A complement, B complement becomes, and the symbol becomes intersect. So those are modified versions using De Morgan's law, but the two in the most pure form are what was written on the previous slide and then this one next to the number 2 right here. But that idea persists. Okay, so that takes care of one of our objectives in this section. The second one is to use Venn diagrams with 3 sets. Now, the truth is, typically in the real world, there'd probably be more than 3 sets, and it is possible to draw 4, but we won't see 4 in this class. 3 is as complex as we'll get. So let's see what that would look like. Okay, so we're going to do the same thing we've done previously, draw the Venn diagram, and then we're going to answer some questions about that picture. So this is all of our data on this slide. We're not actually going to fill anything in here. The universe contains all of these different movies: Howl's Moving Castle, Only Yesterday, Princess Mononoke, Castle in the Sky, Pompoko, Spirited Away, Kiki's Delivery Service, Grave of the Fireflies, My Neighbor Totoro, The Tale of the Princess Kaguya, Porco Rosso, and Ponyo. So this universe contains all Studio Ghibli films, which is, oh, there we go, Studio Ghibli films, the kind of Disney studio in Japan. And then we have 3 sets based on the movie's themes. So set A contains all the movies that have a theme of conflict: Castle in the Sky, Princess Mononoke, Grave of the Fireflies, Porco Rosso, Howl's Moving Castle. Set B contains all the movies with a theme of tradition versus modernism: Castle in the Sky, Princess Mononoke, Only Yesterday, Pompoko, I think it's Pompoko, and Spirited Away. And then set C contains all the elements, all the movies that are about human nature: Only Yesterday, Princess Mononoke, Grave of the Fireflies, Porco Rosso, My Neighbor Totoro, Kiki's Delivery Service, The Tale of Princess Kaguya. So on the next slide, we're going to fill in the Venn diagram. Not enough space to do it all in one place. So remember, we have to identify each item from the universe. So we're going to start with Howl's Moving Castle, and you're going to have to flip back and forth between the slides to look. So Howl's Moving Castle specifically is in set A, and it looks like only set A. So let's start to draw this Venn diagram. It's got to be a big one. And when you draw these again, make sure you draw with a lot of overlap, because you got to fill in items there. I should have even drawn them closer. We have set A, set B, and set C. So like we said, the first item, Howl's Moving Castle, was only in set A. All right. The next item in the universe is Only Yesterday, and we see Only Yesterday in set B and set C. So this is the intersect between set B and set C, but this part here is also in A. It was not in A, it was only in B and C. So we'll fill it in here, Only yesterday. The next one, Princess Mononoke. Princess Mononoke is in all 3 sets. Look through A, B, C. So Princess Mononoke goes in the middle. The overlap of all 3. The next one, Castle in the Sky. Castle in the Sky we see in set A and set B. So it'll go in this little region. Castle in the Sky. The next one, Pompoko. Pompoko we see in just set B. If you feel like you can fill them in on your own, go ahead, pause it, fill it in, and then just check to make sure you're on the right page. Spirited Away, we have in, again, only set B. Kiki's Delivery Service, looks like only in set C. Grave of the Fireflies is in set A and C. We have My Neighbor Totoro is in just C. The Tale of the Princess Kaguya is in only C. Oops, tail. And 2 more. Poco Rosso is in A and C. And finally, Ponyo is not in any of them, so Ponyo is out in the universe. So make sure you've got all items in the same regions. They don't necessarily have to be in the same place. In this region down here of just C, these 3 elements could be floating around anywhere within that little region. And a couple things I want to note. First of all, in this case, we did have an element fall in each of the regions. It's possible that that won't happen. It just depends on the information that you have. You could have a bunch here, 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 and then nothing over here. You could have a whole bunch of elements outside of the sets, but still in the universe. Just make sure you remember to fill in all elements from the universe. Okay, so what we're going to do next is from this visualization, we're going to answer questions. And so now that we're looking at 3 sets, these analyses could be kind of complex. So make sure that you've got your picture good and ready to go, because we're going to do a lot of analysis on it. Okay, so some questions. These are questions from that Venn diagram specifically. The first one is B union C. All right, so let me give you a visual. I'm not going to fill in all the items, just identify where this would come from. We have sets A, B, and C. The union, remember, is the marriage of the 2 groups. So if it's a union and we have B and C, then it's everything that those 2 each have. So we're pulling the elements that come from this shaded region in the picture. Anything that is in any part of B and any part of C. And when I list these, I'm going to specifically list them. I'm just going to list the initials of them because it would be quite complex to write them all. So we have Castle in the Sky, Pompoko, Spirited Away, Princess Mononoke, Only Yesterday, Grave of the Fireflies, Porco Rosso, Kiki's Delivery Service, The Tale of Princess Kaguya, and My Neighbor Totoro. Typically, I wouldn't shorten items like this in the list. In the interest of space, I'm going to shorten them, but for the most part, you should fully list all of the elements. So this contains all of the movies that have a theme of tradition versus modernism or human nature, either one or potentially both. All right, the intersection, maybe we can make this bigger. The intersection is what those two have in common. So the next one, the intersection, is looking at A and B and only where they overlap. So we have A, B, C. Here's circle B, here's circle C. We only want what those two circles have in common. So we really don't even care about circle A being there. You can imagine that it's totally erased. You want everything that falls just in the overlap of those two. So in this case, there's only two elements there. We have Princess Mononoke and Only Yesterday. All right. The next one is another intersection. This is the intersection of A and B. It's only elements that are in both A and B. So let's draw and see where that would come from. We have circle A, we have circle B. If we want the intersection between the two, it's everything that the two have in common. We don't care at all about circle C, it's just what falls in those two. And in this case, we get two from that area. Castle in the Sky and Princess Mononoke. Whoops. All right, the next one starts to get a little bit more complicated. So we have A union, B union C. So if it's a union of two things, A and B union C, a union means everything from both. So since it's a union, since it's a marriage of these two things, I'm not going to worry about using different colors. Since it's a union, everything that I shade is going to come. So first we have circle A, and then we have that being compared with B union C. And since it's the marriage of these two things, it's everything that you see shaded. If it was the intersection, we would only be looking at where the two types of shadings overlapped. But since it's a union, it's everything from each of these two areas. So basically everything inside of the circles. So we get a long list here. Howl's Moving Castle, Castle in the Sky, Pompoko, Spirited Away, Grave of the Fireflies, Porco Rosso, Princess Mononoke, Only Yesterday, Kiki's Delivery Service, My Neighbor Totoro, and The Tale of Princess Kaguya. All right. The next one is B complement. So let's get an idea of where this would come from. And as I'm setting this up, let me remind you that you don't have to find the answers from the picture, but as the ideas get more complex, it becomes really difficult to do it without the visualization. So here's A, here's B, here's C. We want B complement. So B complement is everything outside of B. Complement still means the opposite, so it's simply everything that is not B. So there's B complement. So all items that fall outside of the circle or fall in the shaded region. So we have Howl's Moving Castle, Grave of the Fireflies, Porco Rosso, Kiki's Delivery Service, My Neighbor Totoro, The Tale of Princess Kaguya, and Ponyo. And then the last one we're looking at is an intersection between B complement and A union C. Now, since we're looking at an intersection between these two things, I'm going to use a different color. We have B complement already represented, so let's go with red. And then let's look at what A union C looks like. A union C is the marriage of A and C. So it's everything inside both A and C. Okay, so here are the two different ideas represented visually. We have B complement in white, A union C in red. If we're looking for the intersection of the two, we want where they overlap. Let's go with black. So where do you see an overlap? This would mean you see both white and red intersecting together. And this is why it's really difficult to do this without the visual. It can be done though. We see intersection in this little region right here. So outside over here, this is B, so that shouldn't be part of it. It's outside of B, and the stuff that is in A and C. So this is the area they have in common. If we wanted a union, it would be everything shaded, but we want an intersection, so it's only what they have in common. And now the black represents what they have in common. So we pull all of the elements that fall into this region right here. So it looks like we get Howl's Moving Castle, Grave of the Fireflies, Porco Rosso, Kiki's Delivery Service, My Neighbor Totoro, and The Tale of Princess Kaguya. All right, so again, you don't have to draw the visual every time, but I think it's really helpful. And as you see the ways that these are connected with intersections, unions, and complements, there's a lot of different ways that they can ask you to pull these things together, especially once we get to 3 sets. So I would suggest using the visualization. Now this one did ask for the Venn diagram, so the initial Venn diagram would have to be there, but this process of shading, it's really up to you if you want to go that route or not. All right, so let's go to a practice problem. So you have the picture already. In this case, you didn't have to draw the Venn diagram, but go ahead, pause the video, and then go through the process and see if you can fill in all the elements for the given, for the sets they're asking for. Okay, all right, so let's see if we're on the same page. So the first one we're looking for is A complement. So here is our circle A. A complement is everything on the outside of that. You can imagine all this being shaded. So it's all the elements that fall outside of A. So we have 5, 7, 8, 11, 12, 14, 15, and 13. If you wanted to see, I guess we could do red. Right, here's A. So A complement is going to be everything outside of that. So that's where we pulled elements from. All right, the next one is A intersect B intersect C complement. It's a bit of a tricky one. So let's first think about what's inside the parentheses, and then we'll know, okay, we need the complement of that, the opposite of that. So we have A intersect B intersect C. Here are the 3 circles. If we're looking for the intersection of all 3, then we want what's inside of this region right here, right? That's what's inside the parentheses. But we want the complement of that, so it's going to be everything outside of that region. So A intersect B intersect C, complement is not everything inside, everything outside. There's their intersection of the three. You want everything outside of there. Whoops. So it looks like we want 10, 4, 13, 2, 6, 14, 15, 5, 7, 8, 11, 12. And as usual, you can write these numbers, these elements, in whatever order you want to. It doesn't have to be the order that I list them. It doesn't have to be numerical order. All right, the next one is a simple union of A and C. I'll give you the visual of it. Union of A and C, so here's circle A, here's circle C. The union means everything in both of them. So it's going to be everything inside both circles. Whoops. There we go. So we want 10, 4, 2, 6, 1, 3, 9, 14, 15, 11, 12. The next one is an intersection of B and C. Intersection is only what they have in common. So we have circle B and we have circle C, and here's what they have in common. That's where the two circles overlap. So we list the elements that fall in that region. We have 1, 3, 9, 14, and 15. If you're doing this on paper, you can try using a tissue to kind of overlay on the paper, and then maybe using a highlighter to draw, and you should be able to get the same effect as what you're seeing on here, if this is helpful to you. All right, the next one. The next one, we have A complement intersecting with B intersect C. So let's do these in separate colors. We have A complement. Let's shade that. A complement is what's on the outside of A. Then we also have B intersect C. So here's circle B, here's circle C. We want their intersection, so it's going to be everything in this zone right here. And if we want the intersection of those two things, I guess let's do orange. The intersection of those two things is where they overlap. So where do you see both the red and black on top of each other? And that's in this one area right here. Intersection. Intersection feels more complicated because you got to look for what they have in common, but union is just everything from both. So for this one, we only want elements that fall in that orange shaded region. So we get 14 and 15. And then finally, the one that I feel I'm most likely to see mistakes on, which is filling in for the universe. The universe is everything inside the picture, not just what's outside of the circles. So not just the 5, 7, 8, the universe is everything there. So the universe has all of these numbers. You can write them in order, or you can list them as you see them. 10, 4, 13, 2, 6, 1, 3, 9, 14, 15, 11, 12, 5, 7, 8. Or you could list them in order. Whatever works for you is totally fine. But the universe should have all of them, not just the elements on the outside here. All right. If you need to rewatch that part, please do, because you're definitely going to see questions like this. All right, so the previous question, we filled in the Venn diagram specifically. In this question, we were given the Venn diagram and then just made some analysis. But now we're going to expand a little bit further. So instead of identifying the specific items in each of the regions, we're going to identify how many are there, or maybe describe them in words and then try to describe them in symbols. Okay, so we have all this information here. This is something I found online, so this doesn't represent anyone that I'm familiar with. The first circle up here, which we would typically call A, has people with blonde hair. So I'm just going to call them sets A, B, and C so that they're what we're used to. So all of these people have blonde hair. Then the second set, B, contains all people older than 8. And the third set on the bottom here, C, contains all the boys. All right. So like I said, sometimes we don't need to list all the people that are there. What we're really doing with sets is being able to deal with large quantities of information. So this is a small quantity of information, but you can imagine if we were doing this for an entire school, it would be littered with names and would get too complicated. So sometimes you'll see numbers there, and we'll see that eventually. But what I want to do now is kind of identify all the different places that a student could fall. So you can see a whole bunch of names here, but think about it. How many different, if I have another student, how many different places is it possible for a student to fall in this picture? Typically, I hear people saying either 7 or 8, so let's go ahead and see. There's definitely 7 in that we have this first one up here, 1, 2, 3, then 4, 5, 6, 7, but then don't forget the one on the outside, so there are 8. So what we're going to do first in this case is just identify a name for each of the regions. So there are 8 different regions a person could fall, so we'll call just blonde hair A, people with blonde hair and that are older than 8 B, people that are just older than 8 C, D, E, F, G, and H. Okay. All right, so the first question, how many people are in zone A? So we have the Venn diagram. Sometimes you're going to see this in chart form. And so maybe you'll want to make the Venn diagram and then count. It's up to you. But people in zone A are people that only have blonde hair. So that would be one way to look through a chart. So how many people are there? In this case, we have 2. Sometimes the number will be more important than specifically being able to say who they are. Okay, how many people are in zone F? In our case, here's zone F. We have just 1 person. And then how many people are in zone H? Zone H is on the outside here, so it would be anyone that fell outside of the circles, any of the circles. Again, we only have 1. All right, but that leads us to the next part. The ultimate goal is to be able to describe a specific zone in symbols. But in order to do that, I think it's much easier to identify or describe the zone in words. So let's first go to zone F. How do you classify someone that falls in zone F? People in zone F, they're boys and they're older than 8. But it's much easier if you use all 3 of the sets to describe things. So in words, we have boys and older than 8. And try to use the connectives of and or, because that's how we'll translate back to symbols. And then they are boys and they are older than 8. If they don't fall in this other circle, then they don't have blonde hair. And then let's try to take that sentence and translate it to words. So we've identified, you can see they're all being pulled together with the word and, so something and something and something else. So remember, the and symbol is your down symbol. So the first criteria says boy. Boy we've identified as set C. The second criteria is older than 8. Here's older than 8. We've identified that or labeled that to be set B. And then the last criteria, blonde hair, it's people that don't have blonde hair. So if it's not A, then we would symbolize it with a complement. So this is one way to give a description for this in words and then also in symbols. It's C and B and not A. If you were to go through the process and shade for what this would look like, you would ultimately come up with this zone being shaded and that zone being shaded alone. All right, let's do another example. The next one, let's do zone A in first words and then symbols. So zone A in words. And again, I would suggest trying to use all three of the set descriptors because you'll have to use them all in symbols. So zone A in words. These are people with blonde hair and people that are not older than 8 and not boys. These are really basic sentence translations to be able to convert to symbols. So people with blonde hair is set A, and not older than 8, so B is older than 8, not B, is B complement, and not boys, so and, set C is boys, so and not C. Another way you could go through this description, and actually we're going to do this instead of describing zone H. This is an alternate. For zone A. You could also say people with blonde hair and people that are not older than 8 or boys. Whoops. And so they're not either one of these. They're not older than 8 or boys. So this translation, they're people that are blonde, this is still A, and not older than 8 or boys. If we're saying that the things following the word not, it's both of these, we'll use parentheses and put the complement on the outside. And they're not older than 8, which is B, or, which is union, boys, which is C. And so you'll see here, this is a totally different way to write the symbols, but ultimately it represents the same thing because this piece specifically is using De Morgan's law. Remember, this is one of De Morgan's laws. If you have a complement on the outside, it can get applied to each one individually and then flip the symbol. So in words, you could say people with blonde hair and not boys and not older than 8. Or you could say people with blonde hair and people not older than 8 or boys. It's not either of those two things. And those are two different ways of describing the same thing in words, which translates to two different ways symbolically, but they all represent the same thing. All right, so in this video, we looked specifically at De Morgan's law, being able to write something symbolically and in words in two different ways. And then we also looked at sets with Venn diagrams with 3 sets. So we filled in the Venn diagrams on our own, then we answered questions, and then we also extracted information from those pictures. You don't always have to draw the picture unless you're asked to do so, but the visuals are usually pretty helpful. So I will see you soon for another video.